Artificial intelligence, AI, has become a transformative force in the way we create and experience visuals. From generating images, graphics, and diagrams to designing intricate sketches, AI is revolutionizing content creation across various domains. Today, many people are exploring the potential of AI-based tools, and the discussion around its capabilities is omnipresent. Whether it's the process of converting text prompts into vivid images, transforming static images into dynamic videos, or modifying existing visuals to create new iterations, AI has opened a plethora of creative possibilities. The broad applicability of AI in visual content creation has captivated artists, designers, researchers, and enthusiasts alike. It is now possible to input a text description and watch as AI algorithms bring that concept to life in the form of a digital image. Similarly, tasks like adjusting image aesthetics, applying specific artistic styles, or generating variations of an original design can now be accomplished with remarkable ease. This dynamic interaction between human creativity and AI technology is driving unprecedented innovation, but the road is far from perfect. A question that often arises is, how exactly does AI produce such intricate and accurate visuals based on textual or visual input? The answer lies in the use of trained neural networks. Neural networks are computational models inspired by the human brain, consisting of layers of interconnected nodes that process and analyze data. These networks learn patterns, relationships, and features within vast datasets, enabling them to interpret input prompts and generate outputs that align with the provided instructions. One defining feature of these systems is their ability to combine elements in creative ways. For instance, they can merge different artistic styles, integrate diverse ideas, and synthesize complex characteristics to create visuals that are both contextually accurate and visually appealing. This capability is what sets AI apart in the realm of generative content. The field responsible for these developments, generative AI, focuses specifically on using artificial intelligence to create new, original content rather than merely analyzing or classifying existing data. Despite these advances, the technology is not without its challenges. While AI can generate incredible visuals, its accuracy often depends on the quality of the training data and the nuances of the input prompts. Additionally, certain biases in the training datasets can lead to limitations in how well AI responds to specific, nuanced requests. While the ability to create visuals through AI is impressive, there are instances where the outputs fail to meet expectations. A critical question remains: are the current capabilities of AI sufficient, or is there still significant work to be done to train these systems for better accuracy and reliability? To understand these limitations, let us delve into specific examples. Imagine you provide an AI system with a prompt to generate an image of a tennis player serving or playing on a tennis court, specifying that the player should use their left hand. Upon reviewing the results, you are likely to find that most of the images depict the player using their right hand instead. This discrepancy highlights a recurring issue in AI systems. They often default to what is most commonly represented in their training data. Another common example involves clocks. Let's say you prompt the AI to create a clock, or a group of clocks, displaying a specific time, such as 6:25. At this time, the hour and minute hands should be positioned relatively close to one another. However, instead of producing the requested time, the majority of the generated visuals will show clocks displaying 10:10. This is a well-known issue in visual content generation, as 10:10 is the default position of clock hands in most stock imagery and datasets used to train AI models. Even if you modify the prompt to request another time, such as 12:05, the same issue persists, with the output defaulting back to 1010. Let's consider yet another scenario. Suppose you ask the AI to generate an image of a person wearing a wristwatch on their right hand. Despite this explicit instruction, the output will most often show the person wearing the watch on their left hand. Similarly, if you provide a prompt to create an image of someone writing with their left hand, the vast majority of results will depict a person writing with their right hand. These examples underscore the fact that AI systems are heavily influenced by the biases present in their training datasets, where certain patterns such as right-handedness or specific clock orientations are disproportionately represented. To address these issues, AI developers employ a technique known as reinforcement learning. Reinforcement learning is a type of machine learning where models are trained to make decisions or generate outputs based on a system of rewards and penalties. In the context of visual content generation, reinforcement training can be used to correct biases by rewarding the AI for producing outputs that align with specific prompts and penalizing it for inaccuracies. For example, when an AI generates a left-handed tennis player as requested, it receives positive reinforcement, encouraging it to produce similar outputs in the future. Conversely, when it defaults to a right-handed player, despite the prompt specifying otherwise, it incurs a penalty. Over time, this feedback loop helps the AI model improve its accuracy and responsiveness to user inputs. However, despite the promise of reinforcement training, it has not yet fully resolved the biases in AI-generated visuals. This is likely because the underlying datasets used to train these models still contain an overwhelming number of examples that reinforce these defaults. For instance, most stock images, videos, and other visual references depict right-handed individuals, clocks showing 1010, and similar patterns. As a result, AI systems tend to replicate these patterns, even when the prompts specify otherwise. When users encounter these issues, they often try to refine their prompts by rephrasing them or adding negative prompts, instructions that explicitly exclude unwanted elements. For example, a user requesting a left-handed tennis player might attempt to clarify their prompt by including additional details like a tennis player exclusively using their left hand, with no right-handed actions in the image. Alternatively, they might add negative prompts such as avoid depicting right-handed players. While these strategies can sometimes yield better results, they are not a guaranteed solution. The problem lies in the AI model's reliance on its training data. If the data contains an overwhelming bias toward right-handed players, for instance, even the most carefully crafted prompt may struggle to override this tendency. This highlights the need for more diverse and balanced training datasets, as well as continued advancements in AI training methodologies. The challenges faced by AI in generating accurate visuals are not limited to artificial intelligence alone. Many of these issues stem from the prevalence of certain defaults in online visual content. For instance, a quick search for images of tennis players or cricket players will reveal that the majority of these visuals depict right-handed individuals. Similarly, most images of clocks found on the internet show the time as 1010, as this is a common aesthetic choice in product photography. These defaults are so deeply ingrained in visual culture that they inadvertently shape the datasets used to train AI models. Consequently, the outputs generated by AI tend to replicate these patterns, perpetuating the cycle of bias. This phenomenon underscores the importance of diversifying training datasets to include a broader range of representations, such as left-handed individuals, clocks showing a variety of times, and other less commonly depicted scenarios. Despite these challenges, there is reason to be optimistic about the future of AI in visual content creation. As researchers and developers continue to refine training methodologies and address biases in datasets, We can expect AI models to become increasingly accurate and reliable. For example, incorporating more diverse data sources, applying advanced reinforcement learning techniques, and developing new algorithms specifically designed to minimize bias are all promising avenues for improvement. Moreover, the AI community is actively exploring ways to make generative systems more customizable and responsive to user feedback. By allowing users to provide real-time corrections or adjustments to AI-generated outputs, developers can create more intuitive and user-friendly systems. This iterative approach not only enhances the accuracy of AI-generated visuals, but also empowers users to take a more active role in the creative process. In conclusion, while AI has made remarkable strides in the realm of visual content creation, there is still much work to be done to overcome its limitations. From generating left-handed tennis players to accurately depicting clocks at specific times, the challenges faced by AI systems often stem from biases in their training datasets and the prevalence of defaults in visual culture. Reinforcement training, prompt refinement, and other strategies offer potential solutions, but these methods alone are not sufficient. The key to unlocking the full potential of AI lies in addressing the root causes of these biases, such as diversifying training datasets and developing more sophisticated algorithms. As we move forward, it is essential to strike a balance between optimism and realism. While AI is undoubtedly transforming the way we create and experience visuals, its journey toward perfection is an ongoing process. By continuing to innovate and refine these systems, we can look forward to a future where AI not only meets but exceeds our expectations, making content creation more accessible, accurate, and empowering for all. Please subscribe to my channel if you like the content. To stay updated on our upcoming videos, feel free to share and comment.